We now discuss the solution of a problem from the section Coordinate Geometry. And the problem is based on the concepts of normal to a parabola and the tangent to a parabola. And this question has appeared in the Joint Entrance Examination Main held on 26th June 2022 in the first session. The given question is, let the normal at the point P on the parabola y square is equal to 6x pass through the point 5, minus 8. If the tangent at P to the parabola intersects its directrix at the point Q, then the ordinate of the point Q is, we are given 4 options. Option A, minus 3. Option B, minus 9 by 4. Option C, minus 5 by 2. Option D, minus 2. We are given a parabola y square is equal to 6x. This is the parabola. And it is given the normal at P. This is the point P. Normal to that normal at the point P on the parabola. It's given that it is passing through 5, minus 8. If the tangent at P intersects the directrix, this is the directrix in green, at the point Q, required to find the ordinate of the point Q, that is the y coordinate of the point Q from the given 4 options. That's our given question. We now discuss the solution of the problem in detail. We have the parabola y square is equal to 6x, and writing down in the standard form y square is equal to 4ax, that will give rise to a is equal to 3 by 2. This is your parabola in red color. Y square is equal to 6x, passing through the origin, opening towards the rightwards, and the A in this case is 3 by 2. This is the green one, which is the directrix of this parabola. The equation of that is x plus a is equal to 0. The directrix of the parabola is x plus a is equal to 0, that is x is equal to minus 3 by 2. This is the directrix, x is equal to minus 3 by 2. The equation of the normal at P, the coordinates of the point P is taken in a parametric representation as at square to at. This is the point P, and the normal we know it is given by y plus tx is equal to 2at plus at cube. This is your P, that is the coordinates in parametric representation is at square, 2at, it is the normal. And given the normal at P passes through 5, minus 8. This is 5, minus 8. Now substituting x is equal to 5 and y is equal to minus 8 in the above equation of the normal, then we get minus 8 plus 5t is equal to 2a is 3t plus a 3 by 2 t cube. Agreed. Now simplifying, we'll get a cubic equation in t, that is 3t cube minus 4t plus 16 is equal to 0. What are the real roots of this cubic equation? We don't have methods that are prescribed for our study in our plus 2 level. So we go by trial and error. Now put t is equal to 0. Then 16 is equal to 0. Therefore 16, the remainder is 16. You do not get t is equal to 0 is a root of it. T is equal to 1 is not a root. T is equal to 2 is not a root. Likewise, t is equal to minus 1 is not a root. T is equal to minus 2 if you substitute. That is 3 into minus 2 whole cube. That is minus 24. Minus 24. And this is minus 4 into minus 2. That is plus 8. 8 plus 16, 24. This is minus 24, cancels. And the remainder is 0. Therefore, t is equal to minus 2 is a root. Therefore, t plus 2 is a factor of it. When you factorize this one, the remaining one is the quadratic, 3t square minus 6t plus 8. And if you see the discriminant of this, b square minus 4ac is a negative. Therefore, we do not get any real roots from this. So, the only real root is t is equal to minus 2. This implies t is equal to minus 2. So, in this parametric representation, t is equal to minus 2 will give you the point P. Agreed. We continue in the next slide. T is equal to minus 2. Now, we consider the tangent at P. That is at square plus 2at. In this, a is known, t is known. And the equation of the tangent at at square 2at is ty is equal to x plus at square. Agreed. So, substitute t is equal to minus 2 in this. So, this is your tangent. This is your tangent. So, this will be t is equal to minus 2y is equal to x plus a is 3 by 2. T square minus 2 square is 4. So, simplify. We will get y is equal to minus 1 by 2x minus 3. That is the equation of the tangent at P. And it is given, it is intersecting the directrix at a point Q and required to find the ordinate, that is the y coordinate of this point Q. Now, given the tangent at P intersects the directrix x is equal to minus 3 by 2 at the point Q. This is the point Q. And required to find the ordinate of Q, that is the y coordinate of Q. The x coordinate is anyway minus 3 by 2. X coordinate is minus 3 by 2. So, the coordinate of the point Q is given by x is minus 3 by 2. And in the equation of the tangent, put x is equal to minus 3 by 2. Then you will get the y coordinate, that is minus 1 by 2 into x is minus 3 by 2. Minus 3 by 2, there is no x. There is no x, minus 3. So, when you simplify, there is no x, please. Yes, yes. There is a typographical error. So, when you simplify this, this will be minus 3 by 2 minus 9 by 4. The coordinates of the point Q is given by x is minus 3 by 2 and the y coordinate is given by, in the equation of the tangent, put x is equal to minus 3 by 2. Minus 1 by 2 into x is minus 3 by 2 minus 3. There is no x, please. There is no x. When you simplify, you will get minus 3 by 2 minus 9 by 4. Therefore, the ordinate, that is the y coordinate of Q, is minus 9 by 4. The ordinate of the point Q is minus 9 by 4. That's your answer. Let's look at our options. Our answer, the ordinate of the point Q is minus 9 by 4, appears again as option B. Therefore, the answer to this question is option B. So, that is the detailed discussion of the solution of the problem from the coordinate geometry, which is based on the concepts of tangent and normal to the parabola at a given point. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.